Hello class, today we're on Chapter 1, Lesson 1, Addition. Soon after a child is able to count, he learns how to add. The two operations are closely connected, as anyone who has ever added by counting on his fingers knows. Consider the problem of adding the numbers represented by these two sets of circles. So here we have five circles and we have two. At first, a child finds the answer by counting all the circles. He then learns the fact that 5 plus 2 is equal to 7. Another way to picture addition is by lengths along a line. This figure also illustrates the fact that 5 plus 2 is equal to 7. And we can see on the illustration we have 5 centimeters and we have an additional 2 centimeters, and when we add them together they equal 7 centimeters. The result of adding two or more numbers, called their sum, does not depend on either the order of the numbers or the order which they are added. To find the number of circles in the pattern above, for example, we could add the numbers of the circles in the 4 rows from top to bottom. So we can have 1 plus 2 plus 3 plus 4, or we can go from the bottom up. 4 plus 3 plus 2 plus 1. Either way, we get the same number, 10. In algebra, it is often necessary to indicate the sum of two or more numbers without actually being able to add them. For example, in illustrating the number trick that appears in the introduction of this book, we used a box to represent the original number and a set of circles to represent the number 7. So we had, remember our wonderful box here. Oh, let's see, need to get my pencil. Give me 1 second here. So we had a box that represented a number, an original number, a number that you would have thought of, right? So we have our box, and then we had 7 circles. 1, 2, 3, 4, 5, 6, 7. To represent their sum, we drew them besides or next to each other, right? We put the 7 circles beside the box. Okay, so if I were to do that, I would just show the box, and again the 7 circles together. So we have a box and 7 circles. Instead of bothering to draw pictures like this, it is easier to represent the original number with a letter, such as X. And here is the introduction of the letter X. X represents an unknown. It is called a variable. We call it a variable simply because it varies. So let's go ahead and write X plus 7. The expression x plus 7 means the sum of x and 7. If we replace x with 1, okay, then we would say x plus 7 is equal to 1 plus 7, which is equal to 8. If we replace x with 2, it would be x plus 7 is equal to 2 plus 7, which is equal to 9. So all they're doing here is saying x is equal to 1. What does that equal to? Well, it equals 8. And if we add x plus 7 and we use 2 for the value of x, then the value here would be 9. Because x can be replaced with various numbers, it is called a variable, and I mentioned that before. If we know both numbers being added, such as 4 and 5, we can write their sum of the number, or their sum as a number, 9. If we know only one number, or neither one, the best we can do is to write an expression such as x plus 2 or x plus y. So these are just examples. So we know one number, and that was 2, and we're adding them, so we have x plus 2. So this is an expression. Very important we learn the terminology. It's an expression. It's an expression of a value. We don't know what the value is until we know what what the letter x represents. And again, it can vary. And we also had another expression, x plus y. Now, why do we use the letter y? Well, we're using it because we're saying that x has a particular value, and y could have a different value. So obviously x and y are different. And so let's say we could say um, x is equal to, let's say, 4, right? And let's say y is equal to 3. Okay, so we know that the sum of these two is 7. But we do letters, or we use letters, simply to represent an unknown, a variable. Let's go back to our book here, bottom of page 7, moving over to page 8. The length of the line segment below, for example, is the sum of the lengths of the 3 marked segments. So we have 3 centimeters, then this x centimeters, and then we have 1 centimeter. So to indicate this sum, we can write 3 plus x plus 1, or more briefly, x plus 4. Without knowing the length labeled x, we cannot simplify this answer anymore. So what they did was they simply took, we had a value of 3 centimeters, then we had an unknown value of x, and then we had another known value of 1. So we now have 3 terms in this expression. We had 2 terms up here. Now in this case, we can add the terms that we know. In this case, we know that 3 plus 1 is equal to 4, so we can further simplify this by simply saying x plus 4. Okay, so that is the end of this lesson. When you go into the problems, you'll see that they're going to give you different variations of how to add, and just simply follow the simple basic concepts that we were using in this particular lesson.